Students, today let us see what do you mean by modulus of a complex number. Okay, now here let us assume the complex number z in the rectangular form express iy. If you represent this as a point, you can write this as p of x comma y. P of x comma y. Now for that let us draw the diagram. This is x-axis, y-axis. X is nothing but real axis. This is nothing but imaginary axis. Now we are going to plot this point P of xy in the origin plane. This is origin means you can take this as point P of x comma y. Now you join these two things P and O. Now modulus of the complex number is nothing but the distance of this point P from the origin. Okay, now we want to find the length of OP. How do you find? You know very well. By these coordinates, we can draw a right angled triangle like this. This you can take it as M. Now, this is nothing but x value. This is nothing but y value. Now, we need to find what is this distance OP. Therefore, here we can use what Pythagoras theorem. By using Pythagoras theorem, we can write OP is equal to root of O by M square plus MP square. Isn't it? Now, it is equal to root of what is OM? X. You can write as x square plus what is MP? Y. That is y square. Now, this OP is equal to root of x square plus y square. This is the distance of this point P, which represents cos number z from the origin. Therefore, this is nothing but root of x square plus y square. Now, this can be called as the modulus of the complex number z. Therefore, this modulus of the complex number z is denoted by modulus z, which is nothing but this distance OP. Now, which is equal to nothing but the root of x square plus y square. Now, this is the formula to find the modulus of a complex number. The modulus of a complex number is denoted by what? Modulus of this z. It is modulus. Okay, now here this can also be written as, for our convenience, the root of this is real part square plus imaginary part square. We can write real part square plus imaginary part square. Therefore, you can remember if it is x square plus y square means only for this particular complex number z is equal to x plus iy. If you are remembering this one, whatever be the complex number, whatever the value of x and y, just you can write real part square plus imaginary part square. Then you can take square root. Likewise, you can find the modulus of a complex number. You can say this OP is nothing but modulus z. Therefore, here you can say modulus z is equal to root of x square plus y square. Root of x square plus y square. Now let us see an example how to find the modulus. For example, if you consider a complex number z is equal to 2 plus 3i. Now I want to find its modulus means modulus z is equal to root of, as I told, real part square plus imaginary part. What is real part? 2 square plus imaginary part, not imaginary unit. You can take imaginary part is 3. Just you can square. Whatever be, whether it is minus or plus, just square is always positive. Therefore, you can write 2 square is 4, 3 square is 9. This is root of 13, you can see. Therefore, modulus z is equal to 13. Another example you will see here, if z is equal to 4 minus 3i. 4 minus 3i means, now you want to find modulus z means root of real part square, 4 square, plus imaginary part square, you can write 3 square. You need not bother about this sign because of squaring it becomes positive. Therefore, always remember real part square plus imaginary part square, which is equal to root of 16 plus 9 root of 25, which is nothing but 5. Therefore, modulus of z is equal to 5, you can see. Likewise, we can find the modulus of a complex number. Okay, now let's see properties of modulus of a complex number. Before that, we will see one result. That is, if z is equal to x plus iy, then what is z bar? Z bar is equal to x minus iy. Z bar is equal to x minus iy. Now we know very well z into z bar equal to x plus iy into x minus iy. That is z into z bar. This is of the form a plus b into a minus b, which is equal to a square minus b square. A square means x square minus b square means iy the whole square we can write. Which is equal to x square minus here I square into y square. We know very well this I square is minus 1. Minus of minus becomes plus 1 y square. Therefore, this z into z bar. This z into z bar is nothing but x square plus y square. That is z into z bar is equal to real part square plus imaginary part square. Real part square plus imaginary part square. Just now we have seen modulus of a complex number. Here, this modulus of z is nothing but root of x square plus y square. That is root of real part square plus imaginary part square. Now what is x square plus y square value? Z into z bar. Therefore I am replacing this x square plus y square in terms of z into z bar. Therefore you can write this z into z bar. This is within the root. Therefore modulus z is equal to what you can say, root of z into z bar. Or else while squaring this one you can get modulus z square is equal to squaring this root will go, you will getting z into z bar. Therefore this is another important result you must keep in mind. Okay. Therefore here if z is equal to x plus iy, then modulus z is equal to root of z into z bar, or you can say modulus z square is equal to z into z bar. This result you must remember always. Okay, then we can easily do this exercise. Therefore these are very important things. And also see here if z is equal to x plus iy and z bar equal to x minus iy. Now you want to find modulus of z bar. Modulus of z bar is equal to root of, as I told, what is modulus of z? Real part square plus imaginary part square. What is real part here? X square plus what is imaginary part there? Y. Then you can write y square. This modulus of z bar is also x square plus y square. Similarly, you try to find modulus of minus z. Modulus of minus. This is z. What is minus z? You can consider minus z as minus x minus iy. This is minus z. Now we are going to find out modulus of this minus z. Then again you will be getting whatever be the value of z. While finding modulus, you have to write only real part square plus imaginary part square. Therefore, what is the real part here? Minus x the whole square plus imaginary part means minus y the whole square. Now which is equal to root of x square plus y square. Root of x square plus y square. Now therefore look at these three results. This is, look at this one. This is result number 1. This you can take a result number 2, and this you can take it as result number 3. Look at these three results. Right hand side, root of x square plus y square, root of x square plus y square, root of x square. From these three things we can say modulus z. We can say this modulus z is equal to modulus z bar is equal to modulus of minus z. All these three are equal to root of x square plus y square. That is real part square plus imaginary part square. This is another important result. Therefore, whether it is z or it is z bar or it is minus z, whatever be, its modulus is nothing but root of real part square plus imaginary part square. Now let us see the properties. First you can take properties. That is, first you can take two complex numbers z1 and z2. Take its modulus. That is, the modulus of product of two complex numbers is nothing but product of their moduli. Modulus z1 into modulus z2. Similarly, we can say modulus of quotient of these two complex numbers is equal to quotient of their moduli. Modulus z1 into modulus z2 we can write. Okay. Now, this is one property. Now, this is another property. Next is another property. First, you can take z power n. You can take modulus for this one. Now, this is nothing but first you can take a modulus, then you can raise to the power n. These two can be interchanged like conjugate. Okay, next one. The next one is, as already told, real part of z less than or equal to modulus z. Similarly, the next one is imaginary part of z is less than or equal to modulus z. Real part of z always less than or equal to modulus z. Similarly, imaginary part of z is always less than or equal to modulus z, you can say. For example, if you consider z is equal to 3 plus 4i. 3 plus 4i. Now, what is the modulus z? Is equal to root of real part square plus imaginary part square, means 3 square 9n plus 4 square 16, which is equal to 5. This is modulus z. Now, what is the real part of z? Real part of z is equal to 3. Now, what is the modulus z? Is equal to 5. You compare these two, which is smaller? Real part is smaller. Similarly, what is the imaginary part of z? Is nothing but 4. Now, what is the modulus z? 5. Now, you compare this, which is smaller. These two things are smaller. Suppose you have like this, z is equal to 3. This is a complex number. You can say plus 0i. What is the modulus z? Modulus z is equal to root of real part square plus imaginary part square is 9n, which is equal to 3. Modulus z equal to 3. Now, what is the real part equal to 3 and what is the modulus z is equal to 3? You compare these two are equal. These two are equal. Therefore, real part of z may be less than the modulus z or equal to the modulus z based on the given value of the z. Therefore, in general, we can say real part of z is always less than or equal to modulus z. Similarly, imaginary part of z is also less than or equal to modulus z. Okay. Now, today we have